Hello everyone. I hope you all are good and you all are practicing questions. Let us for now do this one. So what is said in the question? There is this mass M and then there is this mass M. They are connected together with the help of a string. This string is massless. Pulley in between is also massless. So in that case, tension throughout the string will be same. So let's say here tension is T, then here also tension will be T. And tension direction I'm always taking like this because tension always acts away from the body. So you have to draw it like this. Now what else is given? This angle is theta and sine theta is equal to how much? 4 by 5. So theta is sine inverse 4 by 5. Now this surface is not frictionless. There is friction upon it. Surface is rough, right? And then we are said that largest value of m for which equilibrium is possible is this. So what can be the largest value of small m? So that system, this m and small m connected via string will stay in equilibrium is capital M. अब देखो जैसे जैसे ये small m heavy होगा, it will have tendency to go down and in that case it will try to take this mass lying on incline up the plane. ठीक है? So when we are talking about this small m having largest value for equilibrium to be possible, we are actually talking about friction, or we are simply talking about this m mass having tendency to slide up. और अगर ये इसकी टेंडेंसी अपवर्ड स्लाइड करने की होगी, इन दैट केस फ्रिक्शन हियर विल एक्ट इन द डाउनवर्ड डायरेक्शन. ठीक है, सो दिस थिंग वी नीड टू फिगर आउट. फाइंड द स्मॉलेस्ट वैल्यू ऑफ m for which equilibrium is possible. Now what will be the smallest value of m for which system will be in equilibrium? And when you are talking about the smallest value of m, in that case basically you are talking about this mass will have tendency to go up because this has the smallest mass, and this will have tendency to go down. So in the second case, in this case, friction on the mass lying on the incline will act up the plane. So यहाँ पे friction का role है दोनों ही केस में different direction में लगेगा. चलो अब इस क्वेश्चन को सॉल्व करते हैं. सबसे पहले तो फर्स्ट केस में when we are talking about small mass m having largest value equal to capital M for equilibrium to be possible. So let's talk about this situation where this small mass M is having how much value? This is having value equal to capital M. So in this case, here tension T, this will have tendency to slide up, and in that case, friction will act down, and then there is one more force, mg, and then there is this force, normal reaction, acting on the block. अब आप देखो इक्विलिब्रियम इक्वेशन हमें लिखना है. अगर आप इसका इक्विलिब्रियम लिखोगे, इस पे फोर्सेस और क्या क्या लग रहे हैं? mg. So in equilibrium tension will be equal to mg. So this is the first equation we are getting. Now what about writing equation of this mass lying on the incline? So first of all we need to see if we need to break these forces or are they all aligned इन द रिक्वायर्ड डायरेक्शन. सो सबसे पहले हमें ये देखना होता है कि जो ब्लॉक है उसका स्लाइडिंग टेंडेंसी किधर है. It is in race, right? So in order to decide x and y axis, we need to see in which direction it has tendency to slide. So यहाँ पे देखो इस plane के along ये slide कर सकता है. Take this as x axis. So perpendicular to it will become y axis. Now try to look at which forces are not aligned along x and y axis. तो कौन से forces aligned नहीं है? T, N and F are aligned along x and y axis. Either x की तरफ है या y की तरफ है, right? mg is not aligned, so this angle will be theta, because if angle between two line is theta, angle between their perpendiculars is also theta. mg को आप break कर लो. So here mg cos theta and here it will be how much? mg sin theta. ठीक है? So if you talk about vertical equilibrium of this mass m, you will be writing n is equal to mg cos theta. ठीक है, let's call it equation 2. And then if you talk about horizontal equilibrium, that is equilibrium along x axis, you will be writing what? You will be writing n, sorry, n को मैं कहाँ से लिख रही हूँ देखो, this is slip of mind. So we will be writing t is equal to f plus mg sin theta, right? And f will be equal to how much? Friction को हम क्या लिखते हैं? mu n, maximum friction. We will be writing as mu n. So tension को आप क्या लिखने वाले हो? Tension is your mg basically, and we don't know here if maximum friction will operate or not. दैट इज ऑल्सो नॉट क्लियर हियर. सो एक काम करते हैं, सिंपली एफ को एफ रहने देते हैं. दिस इज एम जी बिकॉज वी डोंट नो राइट लिमिटिंग कंडीशन. But again this will be limiting condition. Why? Because we are talking about largest value of m for which equilibrium is possible. So friction will help maximum in letting this happen. ठीक है. So f will be at max, but still let us write it like this: f plus mg sin theta, or mg sin theta is how much? 4 by 5. So f max will be how much? Mg minus 4 mg by 5. So that is your mg by 5. Okay? So this is the value of friction that we are getting over here. Now let us talk about second case where m is the least. So let's say what we are asked. We are asked a smallest value of m. Let's say smallest value of m is m, small m. And in that case, this m mass will have tendency to go down and friction will act up. Okay? So what are the forces acting? Tension T up, and here tension will be different. So let's indicate it by T dash. And this is F here. Let's call it T dash. एंड व्हाट आर द अदर फोर्सेस? अब यहाँ पे आप देख लो, दिस इज mg का एक कंपोनेंट इधर की तरफ जाएगा, दैट इज योर mg sin थीटा, एंड देन दिस इज योर mg cos थीटा, एंड देन दिस इज योर व्हाट? Normal reaction. Let's say this is n dash. So by vertical, I mean by equilibrium of this mass, you will be first telling T dash is equal to mg. ठीक है. So first equation we have got for this one. And now let us write equation for this block. So vertical equilibrium agar aap likho, you will be writing n dash is equal to mg cos theta, and let us call it equation 2, though it is not required, but still for equilibrium condition we are writing. And here T dash plus F will be equal to how much? It will be mg sin theta. ठीक है. So T dash is how much? Mg. What is the F? As I told you in previous case also, this F is nothing but F max, right? And it will operate because we are talking about maximum mass of M for which system will be in equilibrium. Here also maximum friction will operate because it will, I mean, goal is to keep it at equilibrium and it has tendency to slip down. So friction maximum operate karega to help it happen. Okay? So mg plus F is how much? Mg by 5. So यहाँ पे आप लिख लो mg by 5, and this is equal to mg sin theta. So mg into 4 by 5. ठीक है. So this is going to be how much? Small mg is equal to mg 4 minus this is 1 by 5. ठीक है. So g will get cancelled. M is equal to how much? 3m by 5. So this is going to be your answer. So in this question, you simply were required to understand ki, why we are talking about maximum value of m for which equilibrium can be achieved and minimum value of m for which equilibrium can be achieved. So basically we needed to play with the direction of friction, nothing else. And after that we just need to write equation, which is quite easy in this case. So I hope you have understood, but if you have any doubt, you can always let me know in the comment section. Take care of yourself, bye bye, and keep on solving more number of questions.